Section 2.3, Postulates and Diagrams. So we're looking at some postulates on our points, lines, and planes. A lot of these are things we've already discussed. We're just formalizing them. And then we'll look at how that relates to diagrams and what I can know for sure when I'm looking at the diagram. Postulates are rules that are accepted without proof. So these are our basics of geometry, what we set up as the rules we use to show other things. As we go along, we'll see theorems. Theorems are proven from other proven theorems and postulates. Okay. So postulate 2.1 says through any 2 points there exists exactly one line. Okay. So if I have 2 points here, there's a line that connects them, and there's only one line that connects them. Postulate 2.2, a line contains at least 2 points. Postulate 2.3, if 2 lines intersect, then their intersection is exactly 1 point. So we draw 2 lines, right? They have to intersect. They have to intersect at only one spot. They can't intersect at multiple spots. Postulate 2.4, through any 3 non-collinear points, there exists exactly one plane. Okay, so we look at the 2 points up here and another point down here. That defines the plane that is the paper. Right? If I have 3 points here all on the same line, that could be the paper, but it could also be something coming up like this. That's why they need to be non-collinear, which means they're not on the same line. Postulate 2.5, a plane contains at least 3 non-collinear points not on the same line. Postulate 2.6, if 2 points lie in a plane, then the line that contains them lies in the plane. So this is saying if I have these 2 points, the line that contains them can't come up out of the paper and go back down. It has to stay on the paper. And then postulate 2.7, if 2 planes intersect, their intersection is a line. And I generally use a wall and a floor for this example. If you look at a wall and the floor, when they meet, they don't meet at one specific spot. They meet at the entire base of the wall. Okay. A line is a line perpendicular to a plane if and only the line intersects the plane at a point and is perpendicular to every line in the plane that intersects at a point. So if I have this coming down here and I have a perpendicular for a line this way, it's also perpendicular to that line. So example 1, state the postulate illustrated in the diagram. So we have 3 points here that aren't on the same line. This is a plane. So this is 2.5. Actually, do 2.4. So through any 3, not because the 3 non-collinear points come first, not second. So it's 2.4, not 2.5. Any 3 non-collinear points then there's exactly one plane. Example 2. Use a diagram to write examples of postulate 2.2 and 2.7. So 2.2 says a line contains at least 2 points. So x, y, that line is 2 points, and that's also known as line A. So line A contains x and y, which is 2.2. 2.7 says if 2 planes intersect, their intersection is a line. So I have plane Q, which is the vertical one, and I have plane P, which is the more horizontal one, and they intersect at line B. Example 3 and 4 are asking us to sketch. So sketch a diagram showing RS perpendicular to TV intersecting at X. So there's a lot of things you can do here. RS is a line segment. So I want to make sure I have dots there where that ends. TV is a line. So I have those 2 points and I have arrows. And this is X. Now that is not showing that they're perpendicular because I have no way of knowing they were 90. So I want to show the box here. Okay, and the box there showing that it's perpendicular is more important than the direction of the line. If it didn't look 90 but it was marked 90, that is what we want to see. All right. So sketch a diagram showing line TV intersecting PQ at W so that TW and WV are congruent. So I have line TV. I have line PQ. They intersect at W. And again, I don't know for a fact that they're congruent just by looking at the picture unless I mark it in some way. So I want to mark those two things as being congruent. Right. Then example 5 is asking us to use the diagram to see if these are true or not. Okay. So ED and C are collinear. ED and C, I can see they're all on this line, so that is true. The intersection of BD and EC is D. So BD is here, EC is here. That is true. BD is perpendicular to EC. I have that intersection. I don't have anything indicating that those are 90. So this is false because I can't determine it to be true. Same thing here. I don't have the 90. So this is false because it can't be determined to be true. So if they don't show it to me, it is false. Okay. So that is the end of section 2.3.